Alright, okay, let's look at this question. We talk about the concept of parallel vector. So given that there are 3 points and show that this is parallel to this vector. So before that, I have to revise, right? What is the meaning of parallel vector? So if I said vector A and vector B are parallel, when they are parallel, we can relate it by a scalar, right? Or we said there is a scalar multiplication of vector B. A is the same as the equals to the scalar multiplication of vector B, right? As long as you can rewrite these two vectors and relate by a constant k in the form of equation, then these two vectors are parallel. So if let's say the k is a positive, k is a positive value, so definitely these two having the same direction, right? So if k is negative, they are parallel also, but they have opposite direction. Means that if this is positive, vector A and vector B will have the same direction, but just maybe they just have different magnitude. So but if the k is negative, they are parallel. Means they have the same gradient, but they have opposite direction, right? That's as long as you can rewrite it as A equals to kb, then you can show that these two vectors are parallel. So this is the concept, a very important concept. So when you want to show two vectors are parallel, you can relate it by using a scalar multiplication. All right, let's relate this concept to this question here. So given that P, Q, and R, right, show that P plus Q minus R. Okay, that's all. All right, we focus on how to finding this first. So vector P sum with vector Q minus with vector R. As you know that vector you can sum, right? Vector P sum with vector Q, you can add up. So vector P is -1, -2, 6. Usually I will write in column form, okay? Column vector form. Easy for me, right? I don't need to rewrite all the ijk. So 3, 4, 5. So -1, -2, 6. 3, 4, 5. Then later on minus with R, right? Minus with R. So R will be -2, 1, -1, right? -2, 1, -1. So, and let's sum up all this. So we have -1 plus with 3 minus +2, right? And -2 plus 4, minus with 1. And 6, right? This is the way we're doing addition and subtraction for vector. So 6 plus 5, +1. So let's check what we were getting. So 5 minus 1, you have 4, right? 4. And 4, right? 4. Minus 2 minus 1, -2 plus 4, 2. 2 minus 1, you have 1. So 6 plus 5, 11. 11 plus 1, you have 12. Right? 4, 1, 12. So, and the question is asking to show that this vector, after you're doing the addition and subtraction, then this vector is parallel to this vector. So let's see, can we rewrite this vector in the form of P plus Q minus R in terms of K of this vector, right? So very easy. From here I can see that I can factor out the 2, right? I can factorize the 2. So if I factor out the 2, right, I factor out the 2 here. So I take out the 2, so I will have 2 as 1 become 1 over 2, and this becomes 6, right? You see that 2 times 2 getting 4, 2 times 1 over 2, 1, 2 times 6 you're getting 12, right? They can relate by a scalar, which is 2. Means that this two vector is actually parallel and is in the same direction because the k is positive here, the scalar multiplication here. So now you have already showed that P plus Q, since P plus Q minus R is the same as the scalar multiply of 2 with the vector 2i plus half j plus 6k. So then I can say that therefore, right? Therefore, vector P plus Q minus R is parallel. 2i vector 2i plus half j plus with 6k, right? Because they can relate by a scalar, alright? So this is very important concept. I hope you understand how to show that two vectors are parallel. And this is the concept here, right? I think that's all for this video.